Welcome back. So today we're going to be working on reviewing some of our area formulas for our two-dimensional shapes. So we're going to start out with a rectangle. The reason why we're going to start out with a rectangle is because this is the one that you're probably the most familiar with. So when we're dealing with a rectangle, we have two sides that are of the same length. So I'm going to call these W. And we have the other two sides, the top and bottom, are also the same length, so I'm going to call those L. So then when we're finding area, we're going to take our length times our width. So our L times our W. And like I said, that's probably the one that you're the most familiar with, so that's why we started there. Okay, so then I'm going to move up to a square. So for a square, all of our sides are the exact same length, so I'm going to call this one S and this one S. So now when I multiply the side on the left or right, doesn't matter, and the other side together, we get S times S or S squared. So same thing as what we did here. We had these two dimensions, we multiplied them together to get our area. We did the same thing here. The only difference is these are all congruent to each other. So that's why we were able to just call this S. Length times width still works for this. It's just that my length and width are the same number. Okay? So then we're going to move over to a parallelogram. So I've got a parallelogram here. So on a parallelogram, sometimes we have some slanted sides there. So we still want to go perpendicular. You notice this is perpendicular on our square. Our sides are perpendicular. You can go ahead and mark those. Well, we want perpendicular here as well. And if you remember, we've talked before about height is always perpendicular to the base. So we're going to call this H for height. And then since it's perpendicular to our base, we're going to call that B for base. Okay, so this dimension is B for base. This one is H for height. Same thing as we did here with our rectangle. We're going to take the base times the height. Okay, they just have different letters. And again, these will all work for each other. You just have to understand length and width have to be perpendicular to each other. So that's why we used the terms base and height here. For a triangle, let's say I start out with a rectangle or a square or a parallelogram. There's actually two triangles in one of these quadrilaterals. So I can take my base times the height, which we just talked about here. But I only want half of it to give me the triangle. So we're going to go 1/2 base times height, or you could even write base times height divided by 2. That would be the same thing. Okay? All right. So then we're actually going to move on to the trapezoid here. So a trapezoid, this is the one that looks like that. It's a trapezoid. So we still have what we call a height. It's going to be perpendicular to our base. Well, we have two bases. We have a base 1 and we have a base 2. The reason why we call those base 1 and base 2 is because they're different lengths. So we need to find the average of those two bases. And to find the average, we're going to add them together and divide by 2. So we're going to take base 1 plus base 2 divided by 2. So that's finding the average of those two bases. And then we're going to multiply that by the height. Okay? Other ways that you might see this, sometimes we also have 1/2 H parentheses B1 plus B2. It's the exact same thing, it's just a different way of writing it. Okay? All right, so let's move on to our rhombus and our kite. Okay, so first thing I want to talk about is our rhombus. So a rhombus is where we have all four sides being congruent, kind of like our square, but we don't have right angles in here. It's smushed a little bit. Okay, so for a rhombus, we're going to be dealing with these pieces here we call diagonals. So we're going from corner to corner. Our diagonals are going to be perpendicular. And we have diagonal 1 and we have diagonal 2. I know those are really small, so make sure that you're listening to the audio for this, or you're going to miss out on some pieces. So we have two diagonals. So for this one, instead of taking length times width or base times height, we're going to take diagonal 1 times diagonal 2. And we're actually going to do 1/2. Okay? So 1/2 of diagonal 1 times diagonal 2. Because if you think about it, if we took this little triangle over here, we could place it on this side. If we take this little triangle and place it up here, then we would have a rectangle with half of the width, but the same height as our D1 and D2. So that's where that comes from. So a kite, the difference between a rhombus and a kite is a kite, we've basically pulled the tail down. We've stretched him out. We still have our two diagonals, and they're still going to be perpendicular to each other. But instead of having 4 congruent sides, we have 2 pairs of congruent sides. But we're still going to use that exact same formula, 1/2 D1 times D2. So the formulas here are the exact same because we could do the same steps. I could take these two triangles, move them over here, and now I would have a rectangle with a width of half of the original kite and a height that's the same. Okay? All right, so then the last one that we're going to talk about today is our circle. So circles, we always have a center, and then we have a radius, which goes from the center halfway out. So for area, we're going to use the formula pi, and then we're going to take that radius and we're going to square it. Okay? All right, so that is all that we have for the review of our two-dimensional shapes, finding area of those. I will see you back tomorrow. Bye.